In this video, we'll be looking at compound interest. Now, compound interest or compounding interest is the interest on a loan or deposit based on both the initial principal and the accumulated interest from previous periods. Now, the formula associated with compound interest is shown. However, in order to understand this formula, we need to know what these variables here represent. So, or these unknowns. So, FV represents the future value. So, this will be the value of the investment in the future, or one can think about it as the total amount that you will repay on a loan. The present value or principal, this is the amount that is invested or the loan that is taken, the amount of the loan for the loan that's taken. R represents the rate, and this is usually given as a percentage. However, in order to use it, it should be converted to a decimal, and we know to convert from a percent to a decimal, we need to divide by 100. N represents the number of compounding periods per year, and T represents the time in years. Now, in some cases, you will be given the time in months, and you need to write this as a fraction of a year. Now, for the compounding periods, it is possible for them to tell us, or it is possible for the loan or the investment to be compounded annually. Now, if it's compounded annually, then n is equal to 1, because that means that it will be compounded one time for the year, so once per year. If it is annually, then semi-annually, then n will be equal to 2, so it will be compounded every 6 months, so that's twice per year, so n is equal to 2. For quarterly, it will be compounded 4 times per year, so it will be, or another way it could be that could be stated is that it would be compounded every 3 months. So every 3 months would result in 4 times per year. Monthly, n is equal to 12, and weekly, n is equal to 52. Now, it could also be compounded daily. So if it is compounded daily, what do you think would be the value of n? You can share your answer in the comment section. Alright, so let's look at some problems. So in this video, we'll be focusing on 3 problems. So for the first problem, Kimon borrows $12,000 for 1.5 years at 18% compounded quarterly. How much money will Kimon repay? So we'll start by writing the formula that's associated with compound interest. And as with almost all math problems, it's always essential for us to write down what we know. So what do we know? We know that we want to find the future value, because the question asks us, how much money should Kim repay? So that's the future value. The present value, remember, or the principal, so that's the amount being borrowed or deposited, and in this case, $12,000. So the present value is $12,000. R, our rate, is very easy to identify because it's given in percentage. So the only thing that we have here in percent is 18%. So converting that to a decimal, we get 0.18. N is equal to 4 because we're told that it is compounded quarterly. And the time is 1.5, because the time is given in years, which is 1.5 years. So now we substitute these values in our formula. So substituting gives the future value to be equal to $12,000 times 1 plus 0.18 divided by 4. So we substitute the value of R and N, and this is being raised to NT, so 4 times 1.5. Calculating this gives us, so calculating the bracket, 1 plus 0.18 divided by 4, and to do this we can simply say 0.18 divided by 4 and then add that value to 1, and we would get 1.045, and 4 times 1.5 is equal to 6. Now this is just a matter of using our calculators. Now for me, I would say 1.045 to the 6th and then multiply that exact value by $12,000, which would give the future value to be $15,627.12. Now just a note, we're talking about money, and when dealing with money we try to round to 2 decimal places. Now in this example, we'll be looking at how long it would take for money to double. So for any sum of money to double at 8% if compounded annually. And once again, we have the formula associated with compound interest. Let's write down what we know. Now, in terms of the present value, this is unknown, so we're talking about any money being doubled. So I'll just use M to represent this present value. And since we want it to double, it means that the future value will be equal to 2M. So if, let's say, my present value is $5,000, if I wanted to double, then that would be $10,000. Sorry, so it'll be 2 times $5,000, right? So that's $10,000. So likewise, in this case, our present value is M, so when it is doubled, it will be 2M. We also have R, which is 8%, and this converted to a decimal is 0.08. N is equal to 1 since it's compounded annually, and T is unknown. Now we substitute this in our formula, and that gives 2M is equal to M times 1 plus 0.08 raised to 1 times T. Now this would be 0.08 divided by 1, which will just give us 0.08. Now we have 2M is equal to M times 1.008 raised to the T. We can now divide both sides by M, so that gives us 2 is equal to 1.008 raised to the T. And from experience, we know that the logarithmic function has the property that we can use to get this from out the power, right? So what we will do now is we will take the natural logs of both sides. So ln2 is equal to ln 1.008 raised to the T. Now applying the property I mentioned earlier, we can write this as ln2 is equal to T times ln 1.008. I hope you guys remember that property. So now we can say that ln2 divided by ln 1.008 will be equal to T. And once again, using our calculators, we can see that T is equal to 9.01 years. So in 9.01 years, any sum of money will double if it is compounded annually at a rate of 8%. And finally, in our third question, a business needs $300,000 to purchase a new machine in 2 years. How much money should they invest at a rate of 10% compounded semi-annually? Now, once again, as seems to be the theme, we write the formula associated with compound interest. And once again, as expected, we write what we know. So the future value is equal to $300,000. So it says the business needs $300,000 to purchase a new machine in 2 years. So this is money that is needed in the future. So in 2 years time. So this is the future value. The present value is unknown because the question is asked, how much money should they invest? So if they're investing it, it means that that will represent, that is the present value. The rate is 0.1. N is equal to 2 because it is compounded semi-annually. And the time is equal to 2 because they need it in 2 years. And once again, it's just a matter of substituting. So substituting the relevant values. So future value, present value is unknown, R is 0.1, N is 2, N is 2, T is 2. We substitute, and that gives $300,000 is equal to the present value times 1.05 to the fourth. Now, how can we solve for the present value? All we have to do is divide both sides by 1.05 to the fourth. So that gives us $300,000 divided by 1.05 to the fourth is equal to the present value. And we can calculate our present value to be $246,810.74. Now that brings us to the end of our video. I hope you have learned something new about compound interest. Thanks for watching.